Hello, and welcome to another science topic today. And you can see if you start setting up your notes that our topic is atoms, ions, and isotopes. So, as we continue to understand more about particles so that we can understand some of the big idea things in space, we're going to answer the question, what is the difference between atoms, ions, and isotopes? If you're doing these notes on the day assigned, it is 1029. Otherwise, fill in whatever date you are taking these notes, and let's get into it. A quick reminder, when we're taking the notes, you only have to write down things that are not in white. The things in white are just a way for me to remind myself stuff I want to talk about, but I don't want you to have to write down everything. So let's get into it. What is the difference between atoms, ions, and isotopes? Let's do a quick review of what we did last time. Last time we learned that everything is made of particles and those particles are always moving. We can call those particles atoms, and atoms are made of protons, electrons, and neutrons. That's what we focused on last time. Today, the focus is going to be changing those atoms. So we start with an atom and then we do something and we get these other terms. So when you change an atom, you might not call it an atom anymore. You might call it an ion or an isotope. So that's the cool part about science, is when things change, right? So something changes about the atoms and makes something new, and then that's when cool science and chemistry things happen. In this class, we're going to just focus on changing the particles in the atom. So what if you change the proton? What if you change the neutron? What if you change the electron? And then that's going to help us better understand some of the things that are in our solar system, especially when we talk about the sun. All right, so go ahead and make this chart. It is 1, 2, 3 by 1, 2, 3, 4. So 3 columns across, 4 rows down. Go ahead and pause the video if you need to make your data table. And what we're going to talk about is, what do you get when you change the proton? What do you get when you change the other particles? While you're doing that, let me show you this amazing chemistry cat joke. What do you get when you mix sulfur, tungsten, and silver? Well, if you look at your periodic table, the symbol for sulfur is S. The symbol for tungsten is W, because it's from a different a name for this element called wolfram. And then the symbol for silver is Ag. So what do you get when you mix sulfur, tungsten, and silver? You get swag. Ha ha ha. See, this is a joke that's funny to you now because you know a little bit more about the periodic table. Okay, back to this. So pause the video if you need to finish setting up your data table. If you're ready to go, here we go. So what do you get when you change the number of protons? You get a new element. The proton is the subatomic particle that identifies the atom. So if you have 6 protons, you have to be carbon. You cannot be any other type of element. If you have 80 protons, you have to be mercury. There's no other element you can be. So if I change the number of protons, you get a new element. So what does that mean? You would be at a new spot on the periodic table. So it would change the properties, the descriptions, the identity. All of that would change because you now have a new element. In fact, the elements on the periodic table that have been made in labs, sometimes that's what they do. They take a smaller atom and they blast it with energy, which chops up the protons. So you get the new number of protons to make new elements. The trouble is that that's not normal or natural. So sometimes the protons just kind of go back together. And so then that's why some of those elements, we say we don't really know what they're used for because they don't exist for very long. But that's what happens when you change the number of proton. You get a new element, so a new atom. If you change the number of neutrons, you would get what is called an isotope. So an isotope is related to the number of neutrons, and that's a special vocab word. We'll talk more about that in a little bit. But what that means is you get a new mass number. So remember, when we were doing particle drawings, we use the mass number to figure out the neutrons, right? Because remember, mass number minus atomic number, or mass number minus protons, gives you neutrons, which means protons plus neutrons equals the mass number. So if you change the neutron, you get a different mass number, and that's called an isotope. The last particle is, well, what happens if you change the electrons? You get something called an ion. So that tiny little vocab word means you have changed the number of electrons. It's not it's not an atom anymore. Atoms are neutral. Isotopes could still be neutral, but they're related to the neutron. And then remember, new element means you've changed the proton. Okay, so what is an ion? So, which means if you've changed the number of electrons, it's not a neutral atom anymore. Remember from the other day that electrons have a negative charge. So if you have less electrons, that means you have less negative charge than before, so you're positive, right? It's kind of like, think of like an attitude. If you get rid of a negative attitude, you are positive. So if you get rid of a negative electron, the atom becomes a positive ion. If you get more electrons than normal, electrons are negative, so then that means the atom will not be neutral, it would be a negative ion. So using that new vocab word, ion is what you have when it's not a neutral atom. So all the particle drawings we did, we thought of atoms being neutral when the protons and the electrons balance each other out, positive protons, negative electrons. When you have the same number of them, that's an atom and it's neutral. If you change the electrons, then that's when you get positive and negative charges. And then that's how atoms start to stick together. But that's getting ahead of myself. You'll learn more about that in chemistry. We don't need to know about that right now. That's not our focus. But just to kind of start making connections to things you've maybe wondered or heard about before. So these are the pieces of changing the atom to get new things. So different elements, isotopes, and ions. Okay, think through that, see if that all makes sense, and then go ahead and do a level 1 type of question. So something right from the notes. So list the 2 things that happen to create that when they're not an atom. What are the other 2 options? That's what I'm trying to get at. So like neutrons and or isotopes and ions is what I was getting at. That was not a very well worded question, but you can come up with your own. Okay, so level 1 type of question from the notes so far. Define an isotope. That'd be another great one. All right, back to it. Now let's talk just a little bit more about what an ion is. So this is a capital I. This is not the word lawn. So ions. So a definition of an ion is an atom that has gained or lost electrons. That's the key thing. If you gain electrons, the atom now is more negative than before because remember, electrons are negative. So in this example, so we start with 9 positive protons and 9 negative electrons. That's the fluorine atom because the negative and positive balance. If we gain an electron from somewhere, now I would have 10 electrons. And then now I've got 1 more negative charge than a positive. So then I have a fluorine ion, which would be F with a -1 charge. So that capital F is the symbol for fluorine. You would get that from the periodic table. It's -1 now because it has 1 more negative charge than positive. So kind of the difference. So this would be the symbol for fluorine atom. This would be the symbol for the fluorine ion if it's negative. If you lose electrons, that's less negative than before because electrons are negative. So then that would equal something that's positive. So for example, you've got neutral sodium here. If it loses something negative, so that just went away, that's what this arrow is showing, you would now have a positive ion because now it's got more positive protons than negative electrons. So then now it's got a positive charge. So those are the 2 options for ions. Losing electrons means the atom is now a positive ion. Gaining electrons now means that the atom is a negative ion. So we change what we call it to show that something has happened. Okay, go and do a level 2 kind of question. A great level 2 question would be sketch a particle drawing for a chlorine ion. That'd be kind of cool. Or sketch a particle drawing for lithium that has lost 1 electron. That would be kind of a cool example. Compare and contrast an ion and an isotope. That would be an okay level 2 kind of question. All right, you finish your level 2 question, then come on back. Let's finish this up. The last thing we're going to review then is an isotope. So remember, the definition is an atom that has gained or lost neutrons. So isotopes are related to neutrons. So in this case, look at this. 8 protons and 8 protons for oxygen. That's what makes it oxygen. So both of these examples are oxygen. And 1, 2, 3, 4, 5, 6, 7, 8 electrons in that example. 1, 2, 3, 4, 5, 6, 7, 8 electrons in that example. So the electrons didn't change. The protons didn't change. That's why it's still oxygen. But look it. This has 8 neutrons in the nucleus. This has 10 neutrons in the nucleus. And then notice we've got a special symbol here. O with an 18. You might notice that that comes from protons plus neutrons, or O with the 16, protons plus neutrons. That 16 is the mass number. That 18 is the mass number. So when you gain or lose neutrons, you get a new mass number because remember, mass number is protons plus the neutrons. So change the neutrons, change the mass number. Yeah, if you change the protons, that would change the mass number too, but it would also change the identity of the atom, and that's not what we're talking about here. So we have been, when we did the particle drawings, we were assuming that we had the most common isotope, and that's the one on the periodic table. So we can do the thing where we round the atomic mass to find the mass number. So that's how we find the mass number normally. But if it's not the most common isotope, we need to show a special notation. And that's kind of what this is showing. The number on the top is the mass number, and then the number on the bottom is the atomic number. So that number won't change if we have different isotopes, but the mass number will change. In fact, if you look at the periodic table quick right now, you will see that the most common isotope for carbon, its mass would round to 12. So the most common carbon in the world has a mass number of 12. So if it's not the most common isotope, again, we would have to show you that and we'd have to give you this mass number. You can also write it out like this, the name carbon with a dash 14. So that's not a negative sign, it's a hyphen, and that's showing you the mass number. So that's why that number is the same as that. Or in this case, it was showing you that oxygen has an 18 mass number because there's 2 more neutrons than normal. This oxygen had a 16 mass number. This is the most common one on the periodic table. And then this is the one that has the higher number of neutrons. So again, the number up top like that is showing you the mass number. So if that number is given to you, you don't have to do the rounding thing on the periodic table because you already have the mass number. So just remember that special notation. If you're trying to find the mass number of something and it's already given to you, use the one that is given. Okay? All right, so related to isotopes, just a couple more ideas here. If the nucleus of the atom, and remember the nucleus is protons plus neutrons, if that nucleus is so big and so unstable that it cannot stay together, it could actually start to fall apart. Like if energy blasts into it, like this is a really big nucleus with lots of pieces. And so if something blasts into it or energy blasts into it, pieces can start to fall apart, and that is known as radioactive decay. We're going to learn a lot more about that when we talk about the sun, but I want you to know that that's related to isotopes. So if you have a nucleus, protons plus neutrons, that cannot stay together, that's called radioactive decay. And then the other thing related to that is if there's enough energy present in that nucleus, 2 or more nuclei could actually connect. So let's imagine that I have one nucleus here, here's 1 proton, another nucleus here, that's 1 proton. Well, 1 proton would be hydrogen. So if you have this hydrogen, and this would be a neutron, this would have 2 neutrons, so these are hydrogen isotopes. So again, to clarify, the positive 1 proton shows you it's hydrogen. This has 1 neutron. This is positive 1 proton, still hydrogen, but now it has 2 neutrons. Okay, that's fine. If these smash together and there's enough energy present, they can make a new nucleus. Still now it has 1, 2 protons and 1, 2, 3 neutrons. But it's the 2 protons that identify the atom. So now this would be helium. So you can make new elements by smashing together nuclei. Now it takes a lot of energy to do that. And so that's why, like I mentioned, sometimes the lab-made elements don't stay around very much because we don't have enough energy to keep those nuclei together. But if you can make that happen, like, for example, in the sun, so we're going to talk more about that later, new elements can be made in the sun because there's lots of energy. So there's nuclei that can smash together and stay together. So trying to make some of those connections between why are we talking about particles and how does this fit into our unit on the solar system? And we'll start making those connections more and more in our next days together. All right, well, that finishes up our information on particles, ions, isotopes, and atoms. So go ahead and do your level 3 kind of question. Generalize, which is kind of like writing a summary. You can do an imagine. Imagine if everything had a positive charge like an ion or something like that. So go ahead and do a level 3 kind of question. And then that brings us to the end of a third day of our unit. So if you didn't do so already, go back and finish any Costa questions. Write your summary for today that asks what is the difference between atoms, ions, and isotopes. And then I do have another worksheet quiz for you. It's not like the past ones where you had to put stuff in order. It's just questions, multiple choice questions about atoms, ions, and isotopes. Most of the questions from the quiz come from today's notes, but some of them were also talked about on the October 28th notes too. So if you need to go back and review any of that, do that. You can keep taking this quiz until you get them all right. If you get something wrong, review that mistake, look back at your notes before you take it again, and eventually take it enough times that you've got all 10 questions correct. So then you kind of know the big important information from today's notes. And then, like I said, there's a little bit from October 28th on there too. All right. Thanks so much for listening and exploring more about particles and atoms and ions and isotopes with me. We'll see you next time.